Let's get started. So you're here at the presentation all about auto testing for Qt applications. Well, not all about, just a gentle introduction. There's actually a bit more interest in this topic than I expected, which is a good thing. I'm glad to see so many people interested in quality. So can I have a show of hands who writes auto tests for their applications? Yep, that's good. Does anyone run them before every commit? Okay, one person claims to do that. It's a little hard to believe. It can be a bit cumbersome sometimes, but today we'll go over some of the tools that are available to you in Qt to help you get to this point for your Qt applications. Okay, so what I want to go over today is, well, consider yourself in this situation. Let's say you have some Qt application and currently you don't have any tests for it. Okay, so you've just got a big app and you really have no way of knowing whether or not it works other than running the application and clicking on some things. Right, so that's where we are now, and I want to get to this point where we have our application and we have a series of automated tests for it. Now, I thought that a good way to demonstrate this would be by taking an existing Qt application and adding some auto tests to it. Right, so the Qt application that I chose is called KeePass X. This is an open source application, cross-platform, and I chose this application because I think it's genuinely useful. It's not just a trivial toy application to write some tests for. I do actually use it on my notebook and sometimes on my N900 as well. So before we continue, I'd like to just give a demonstration of what this application actually does. Okay, so this is a password management application. The basic concept behind it is that we can create a database that contains our username and password for our various services, our internet accounts, whatever. So we can create a database with a password, and we now have an encrypted storage on disk that contains our usernames and passwords. I haven't added any usernames and passwords here yet. What I have done, just to demonstrate this to you, is I have written a little sample dialog application. Okay, so we have here a little dialog that's asking for a username and password. Now, using this password management application, let's say that I make an entry for this account. I put in my username and my password twice to make sure I don't make any mistakes. Alright, so I have my password database open in the background. That's the application running in my system tray. And I can just hit a little keyboard shortcut, and the application has automatically entered the username and password into the form I had up on the screen. Okay, so it's doing this by looking up the title of the window that's on the screen and trying to figure out what username password pair matches that dialog. Okay, so that's basically what this application is. I'll just terminate that. Alright, so now that we've seen this application a little, I can talk in slightly more concrete terms about what I want to achieve. So at the moment, this is just your stock standard Qt build procedure. So this application, if I want to test that it compiles, I can do that by running qmake and then make, and my application will be compiled. Now that's where I am now, and I want to get to this point where I can run qmake and then I can run make check, and my application will be compiled and some suite of tests will be run. So that's what we're going to try to do with this application today. Now, the first thing that the first problem that we come across is that right now we are producing a single application binary for our app, and we can't really do anything with it other than launch it and click on things. So this is a kind of impenetrable shell around the application, and if we tried to write a test program to programmatically exercise bits of code, we can't do it. If you like, the tentacles of the test program cannot penetrate this shell around the application. So at the moment, all we can do is black box testing. And that's fine. So black box testing is basically you run the application, you click on it, you interact with it like a normal user would. And there are some tools that can automate this as well. That kind of testing is fine, but it's not really a complete story. You want to do both black box testing and unit testing, integration testing. This talk is focusing more on unit and integration testing. Okay, so that's our problem. How can we solve this problem? Well, it's pretty simple. We can take our application and we can move bits of it into a library. Actually, we can move pretty much all of it into a library. Okay, so here's our library. Now we have our application and our test programs using the same library. Okay, so since we have a library containing our application code, we can now link against that library and call whatever functions we want, exercise whatever code we want. And you might think that making this into a library is making things more complicated for yourself in terms of deployment. I'm not suggesting that you actually have to deploy your application as a library and a binary. You can use a static library, for instance. This is really just about code separation. Okay. Now, I would suggest that if you are starting a Qt application from scratch, you use this kind of design from day one. You try to write most of your code as if you're writing a library, because you will get more testable code, and generally you will get better designed, more reusable code as well. And one final point about this. Today we're talking about a more kind of traditional Qt application. If you are using Qt Quick, QML, this kind of approach still applies where you, if you have a complex QML application, you'll tend to have data models, algorithms, so forth, implemented in C++, and then your thin QML UI on top of that. So you can still put the data model parts, the algorithms, into your library and test that separately from the user interface. Okay, so how can we actually do that for this application? Well, let's have a look at the structure of the source code at the moment. Okay, I have all these directories. Maybe it's better if I just do that. Okay, so apart from my little sample dialog tool that I wrote, everything else is just under this source directory, and currently that is built straight into my application, meaning that the same binary that contains all of my algorithms, all the code that I want to test, it's linked into this thing with a main function, which means that it's hard to test it independently. I can't currently compile this as a library due to the presence of this main function. Okay, that's not the only problem here. So this is an example of an application that has clearly had some organic growth. So if we have a look at this main function, it starts here and then it goes down and down and keeps going. And yeah, it's a pretty long main function. So the problem here is that we do want to test our, well, partly we want to test bits of our code in isolation, but we also want our tests to be accurate. Since we have a main function here that is setting up all kinds of preconditions that are necessary for our application to work correctly, for example, initializing some custom random number generator, it would be very cumbersome to reproduce this logic or determine what logic is necessary out of this main function for each one of our auto tests that we want to write. Okay, so ideally what we really want to do is right here. Okay, so this is the part where we're entering the main Qt event loop. Really, we want to have the option. We want to say, in the normal case, maybe I want to run the application, but sometimes maybe I want to run a test here. Okay, so this way my automated test would run in an almost identical environment to the actual application, so I get accurate tests. Right, so I need to solve this problem, and I need to extract this this application into an application and a library. So I'm just going to show you the solution to that. Okay, so the first thing that I've done is I've told QMake that I want this to be a library instead of an application. And I've told QMake that I want it to be a static library. And I have asked for it to be placed in the lib directory. So that's what I had to do in the build system. Now in my main.cpp, I had to so a function called main has a special meaning. You don't want to have one of those in a library, so I've renamed this function. And I've also given it the option to run something other than the application. All right? So this is my normal case where I'm going to enter the Qt main event loop, and that's what I'm doing. But I also have the option of passing in any function I want and running that instead of my usual application. And then I've also added an app directory that has a main.cpp. That's very simple. So this is linking against my library, and all it does is it calls the real main function from that library. So I haven't actually changed much here. Let me just compile that for you. Yeah, so I've basically rearranged things so that I now have my library and very thin application on top of that. So here, for instance, it's my static library. And there you see my application that uses that library. And I've also added one small test program that currently doesn't actually test anything. Okay, so this is a skeleton test that we can later fill in. And this is an example of how we can use the testing hook that I added to my library. And all I'm doing is saying this is where I would run the test and then exiting. Okay, so I've successfully split up my application into an app and a library, but I haven't done much else. All right, so we have our empty test program. Now we should implement a real test in Qt style. So what does a test look like in the Qt world? Well, Qt provides a module called Qt test, or sometimes called qtestlib. And this is what a test looks like. You've got a test program. Within that you have a test case. I'll show you how to declare that on the next slide. You can have more than one test case in a test program, but I don't recommend it. It just makes things a bit more difficult to understand. And within a test case you have several test functions, and you might have several sets of test data as well. All of this will be explained in a bit more detail. Okay, so what does a test case actually look like? Well, we're leveraging the Q object system for our tests. So when you write a test, you subclass Q object, and there is a naming convention that we use of naming test cases as tst underscore and then the thing that you want to test. So in this example, let's say that I want to test some kind of printer class or functionality. Got my class, tst printer. I've got to mark it as a Q object. Now my test case can have, it's just a C++ class, so it can have any functions that I want, helper functions, functions to load test data, whatever. The special thing here is private slots. Okay, so if you add some private slots to your test case, these are considered test functions by qtestlib. There are also a handful of special functions, which we'll talk about later. These are also private slots, and if you use these special names, they don't behave as regular test functions, they behave differently. Okay, so how do we actually test things? Well, you basically get a handful of testing primitives. This is the first one, qverify. So you use this when you have some condition that you're asserting to be true. Okay, so in this case, all I want to do is check that my print job is able to print, and qverify job.print will do that for me. Now, there's a second version of this which allows you to add your own data into the failure message. Okay, so in this example, imagine that my print job class has a function called error string, and when there's an error, that gives me a string describing the error. So in that case, I get a failure message like this. It tells me the code that returned false when it was expected to return true, and it outputs the extra string that I asked it to output. Now, I highly recommend that you use this second form, qverify2, whenever the thing that you're testing allows you to. Thing is that if you have written a series of tests, let's say you have a few dozen tests for your very complex application, this can make all the difference in the world between being able to figure out the problem straight away and having to spend hours debugging it. Sometimes having that little bit of extra information really helps. But hopefully you have a better error message than PC load letter. Okay, so this is the other main testing primitive that qtestlib makes available to you. Before we were verifying that something is true. Now we're comparing some value against an expected result. Okay, so in this example, let's say we have this interface to a giant supercomputer, and we've set up some job, and then we want to calculate, and the answer is expected to be 42. If it isn't, this is what we'll get. It'll tell us the value, the first value that I passed to it, and the second value that I passed to it, and it will output them both. And I can see they're not equal, and I expected them to be. Okay, and finally we've gotten up to these special functions that I was talking about. So the need often arises with tests to do some kind of initialization at the beginning of your test case, and maybe you want to clean something up at the end of your test. Okay, so we provide these functions that allow you to do that. It's a pretty simple concept. Basically, we have init test case and cleanup test case. Those are called at the beginning and end of the entire test case. So with my TST printer example, they will be called once at the beginning before any TST printer tests, and then once at the end after all of them. These other two, init and cleanup, init and cleanup are called before and after every test. So every test function. So going back to my printer example again, let's say that I had one test function called print and another one called empty queue. Init would be called before each of those, and cleanup would be called after each of those. Just like in this example here, this indentation shows you the nesting that's at work here. Okay, so we've gone over the qtestlib API a bit, and now we're ready to actually start using that in the test that we have here. So what I want to test here is the autotype functionality. That's what I demonstrated earlier. That's where I asked this program to enter the username and password for me into some dialog. So let's just start by converting my empty skeleton test into an empty Qt style test. So I'm going to add one test function, and I'll just call that autotype. And while I'm here, I may as well introduce another small part of the QTestLib API, which is, if you really need to, you can explicitly cause something to fail. Since I added a Q object, I have to make sure that the mock generated code is included. And I better actually run the test here. Okay, and also because I added a Q object macro, I need to run QMake again. And okay, so I'm compiling my test, and when I run it, I expect it to say failure not yet implemented. Okay, but I now have a skeleton test in QTestLib style, and you can already start to see a few features of QTestLib, such as the logger and the way that it represents passes and failures to you. Okay, now I can show you the body of a real test now. I didn't want to spend time actually writing this in front of you, since it involves figuring out the internal details of this application I'm working on. Of course, when you write a test, the body of the test is going to completely depend on the thing that you're testing. So let's just review this test that I prepared earlier. Okay, so I'm testing my username and password autotype feature. So it makes sense that I want to create some kind of test password dialog to have the username and password entered into. So I've created a simple little widget here, subclass of QDialog. It has a line edit for username and a line edit for password, and it has an OK button. So basically your very stock standard username and password entry kind of UI. Okay, so that's just a helper class. I've also made use, okay, now we're looking at my actual test implementation. First thing to note is that I have made use of the init function. So this is setting up the preconditions for my test. This is going to be run before each test is run, and all I'm doing here is that I'm creating a username password database. I'm ensuring that it contains at least one group. Well, actually, I'm ensuring it contains exactly one group. So I'm creating a database that has nothing in it except this group. So I'm ready to go here. And after each test, I'm cleaning up my database to make sure that anything that's wrong in the database doesn't affect any future tests. Okay, so now this is the guts of the actual test function that's really testing something. And basically what I have to do is I construct my username and password object, and I add that to the database. So here you can see that I'm just using test user and test pass. I've just hard-coded these. Now I'm showing my password dialog. Now one thing that's important to note is that sometimes you'll find yourself in a situation when you're writing a test that you need to do something asynchronous. Now it's a very easy mistake to make, to do something asynchronous and not correctly wait until it completes. So in this example, we're showing that little password dialog that I made, but showing the dialog is potentially an asynchronous thing. It's just a request, so there is no guarantee at this point in time that the dialog has been shown yet. So I better verify that. Okay, so it's only one extra line of code. Now here is the bit where I'm actually performing the auto typing. So it's just one function call, telling it to perform on the database entry that I added earlier. And this also has the same problem. So autotype is, it's clearly an asynchronous thing, given that it's simulating human key clicks into the widget, right? So I can't just do the autotype and then verify that my dialog was accepted. I need to potentially wait for some time. So here I have a very small loop that's basically waiting for only as long as it has to make sure that the dialog has really been deactivated somehow. Okay, now I'm verifying that the dialog really was accepted. So I expect that the autotype entered the username and password and then it hit enter. So that should have accepted my dialog. And it should have input the values that I had earlier, which are test user and test pass. Okay, so that's my whole test. And I've also used init test case to verify a very basic prerequisite, which is that the global autotype application, which is just an implementation detail of this particular application, just verifying that that actually exists, because there's no point attempting to run any test if it doesn't. Okay, I think I compiled that already. Yep. So I can run that. Okay, now that went so fast that you can't tell that it actually tested anything. But we can run this test with, well, if you run the test with -help, whoops. Okay, I can't run the test with -help because there's a bit of confusion with the argument parsing between the application that I'm testing and qtestlib. They're kind of fighting over the arguments. So it's basically it's printed out help for the wrong thing here. But that's okay, because I know all the options off the top of my head. So I can run this test in a more verbose mode, and now it's told me a bit more about what it's really testing. Okay, so here at the beginning it's told me, alright, it verified autotype, that was fine. It did some comparison, that was fine, verify, comparison. Right, so it's testing things and it's passing. Okay. So in the test that I just showed, I had hard-coded a username and password pair. I'd hard-coded test user and test pass. One of the very first logical improvements to just about any test that you write will be to make it work with a variety of test data. Okay, so there's a feature in qtestlib that helps you achieve this. Let's say I have a test function called myTestFunction. If I make a new private slot called myTestFunction_data, that function can do whatever it wants to create a table of test data. So by a table of test data, I mean like I have here. This is a table of test data for the multiply operation, very critical thing to test. And we basically have two inputs and an expected output. And we have 3 different rows of test data. So for example, a typical set of test data, an edge case, so one of the values is 0, and we verify that -1 times -1 equals 1. Okay, so how can I apply that to this test that I've written? Well, it's quite simple. First, I need to create my autotype data function. And I better make sure that I used capital T there. Okay, so I can now establish my columns in the test data table. So I want to have one column for a string username and one column for a string password. So I could run my test for several different sets of usernames and passwords. So I've just asked qtestlib to make a column of q strings called username. And I'll do the same for password. Okay, so that's the column set up. Now I can start to add some rows. So what I usually do is I make my first row just some really typical data. Well, I don't know if that's really typical. I don't know how many people are called test user, but I think you get what I mean. And then I might start to add some edge cases, such as this non-security conscious user has an empty password, and maybe some troublemaker decides that he wants to have a space in his username, and maybe someone else has kind of gotten angry at their computer and just decided to mash on the keys. Okay, so I've set up a little test data table here. Now, one thing I want to point out is that this test data function, there can be anything in here. So any kind of C++ can go in here, which means that you can, if you want to, you can load your test data from files on disk, or you can load them from a database or whatever you want. You can, but whether or not you should is another question, because the more code you put into your test, then the higher the chance is that your test itself has bugs, right? So you might want to keep it simple, but if the need arises, you can do more tricky stuff here. Okay, so I need to change my test function so that it actually retrieves the data from the test table. That is also quite easy. The API for that is qfetch. So I'm fetching my username and password from the data table. And now I need to remove any hard-coded references to my old values. Okay, so I should now be able to compile this test and run it, and we now expect it to be testing 4 times, I believe it was. Okay, so here we go. So my test has been repeated now with several different sets of test data, and here in the test log, it's told me what test data it's currently operating on. Okay, so this is an almost, well, this is, all tests end up using test data, basically, is what I'm trying to say. So let me just make sure I've got this right. Okay. So the last thing that I want to move on to is build system integration. Okay, so we have tests. Let's just imagine that we had more than one test. I wouldn't want to go through and run them all manually, right? So there's this minor extra step that you can do, which enables you to use make check and run all the tests that you want. So as I said, that's very easy. All I have to do is, in my profile, I am telling QMake this should be considered as a test case. Now before I run that, you might wonder, what does it look like if this test actually fails? So let's demonstrate that. So I've opened up one of the classes that is used by this application to do the encryption and decryption. Now let's say that someone wasn't really that familiar with q byte array, and they had read that q byte array from raw data enables them to avoid a copy, and that introduced this memory corruption error here, which is not necessarily obvious if you're just scanning over the code quickly. So let's say that I had made that change. Now, if I were in the habit of just doing make, okay, so everything built, and I believe my application will actually appear to launch correctly if I just start it and don't do anything. But if I do make check instead, okay, the test is now failing. There's a memory corruption error, which basically means that garbage is going to be entered into my username and password field on my dialog. Okay, so if I get myself into the habit of using make check here, then this bug will never make it into the product. So let's say that I've figured out this error now. So I fix it, put it back the way it was. And I know that it's better to do make check now rather than make. So I do make check, everything that needs to be compiled again is compiled. My test runs. Great, it passed, so I verified that I fixed the problem. Okay, so there's a few nifty features to this make check feature. You can specify your own custom test runner and your own custom arguments to the test that you're running. Okay, so basically, instead of running make check, I can run make check test runner equals something and test args equals something, and this is what the result will be. And also, I'll point out that this feature works on any Qt platform which uses makefiles. So although I'm demonstrating this on Linux, it works fine on Windows and Mac, and to a certain extent it works fine for Symbian as well, and Memo is also fine. Okay, so what might you want to do with this feature? Well, here's a few ideas. Let's say that you've got a set of tests and they're all passing, but maybe you want to really make sure that your application is great quality. You could run all of your tests through Valgrind on Linux. So this is a memory leak checking, or generally a memory error checking tool available for Linux. Run all your tests through that, and then you're really verifying that all your code is quite clean in its memory accesses. Okay, maybe you want to run your test on a device. So if you are using, if you're developing for an N900 and you're using Scratchbox, it's literally a 10-line shell script to copy your auto test onto a device and run it there. And you can run all your tests through that script that you've written, like this. Well, you can even run your tests across multiple devices. So we're just using standard make. That means we have access to, say, the -J option. So make -J2 means do what I asked you to and potentially do up to 2 things at once. Okay, so if I have more than one test and I have a script that understands how to distribute them between devices, I can do make -J2 check, and everything will be dispatched for me appropriately. Okay, and finally I might want to run all the tests for my product and grab a set of XML test reports and upload them to wherever. Okay, so I can do a little demonstration of that as well. Let's say that I wanted to do a bit of a ad hoc performance test on my auto test. I can run my test with strace-c, and let's also say that I wanted to create a test report in XUnit XML format. Okay, so you can see that my auto test is running. It seems to be running as normal, but actually it was run through the strace tool. So this is a tool that traces system calls and outputs a summary after it finishes. So my test has been run, and afterwards I've got this nice little table that shows me all the details about what system calls the test made and how much time it took. So if I had a tree full of tests, I could easily apply this to all the tests in the tree. I also asked it to generate a test report. Okay, so it's done that. So once again, if I had a full test suite, I could easily generate a whole tree full of XML files ready for processing by whatever system I have. So this in particular is XML compatible with JUnit and NUnit, the Java and C# testing frameworks. Okay, so the point that I want to make there is that MakeCheck is very flexible, and if you want to have your own kind of test running logic, please use it. So our test is pretty complete now. It would be nice if we had some more, but let's move on to conclusions. The really important thing, actually the most difficult thing, is to design your application for testability. So if you already have a large application that wasn't really designed for testability, there's no easy way to solve this problem. If you're designing something from scratch, try to make sure that everything you write can have an auto test written for it. Test-driven development is a good way to achieve this. Please make sure that you actually write tests. Otherwise, embarrassing bugs like the one that I deliberately put into this application are very difficult to automatically detect. And if you get into the habit of having these auto tests, marking them as a test case, and getting yourself into the habit of doing MakeCheck instead of make, then you're getting regression testing very frequently, and the only cost is the amount of time that you have to wait every time you type MakeCheck. I'll just reiterate that if you have some kind of custom setup, you need to run tests, there's something that you think is missing from qtestlib, Test Runner is a great way to customize the test running process and get what you need into the tests. All right. Okay, so that was all the content that I wanted to show today. Do we have any questions? Yep.
Hi. We are using CPP unit for unit tests. And in the example you give, it's good that because you have GUI elements to interact with, but in that case, this is the software that makes the typing for you. So my question is there a way to simulate user behavior? Like in that case, do you have to type yourself in the test random data? Or is there a way to simulate user interaction with the GUI?
So there is a way to simulate user interaction with qtestlib, but it's not exactly the same as if a user really does it. Basically, what's available is that you can synthesize key events and mouse events, and you can deliver them directly to widgets. But that's not really the same as a real user would do it. If that's your main testing focus, system testing, clicking on things and so forth, we do have a partner, FrogLogic. They have a tool called Squish. That's our current recommendation.
What about combining several test cases in one test program? I'm not quite happy about that. I used it, but XML output, for example, doesn't work correctly if you have several test cases.
That's why I advised against it. So basically, the ability is there in the API, but in some ways it would be better if the ability weren't there, because you get exactly the kind of problems that you've experienced. Other problems are if you have a test program and you have multiple test cases, what happens if the first test case crashes? It's very difficult to determine that had the test continued, then these are the tests that would run. So it's difficult to put into a report, for instance, if you had a test program running test cases A, B, and C. If A crashes, it's not feasible to put into your report that B and C would have been run if it had not crashed.
I have the problem that I'm mainly a Windows developer, and I use Visual Studio. So you can integrate the tests by having an extra test program with the dependency of the main project on the test project, and you can auto-test this by adding a post-build event that starts the test program. But this only works if you have only one test program. So you are caught between.
Yep. So most of what I'm focusing on here is, well, basically what I'm targeting also because of what my day job is I'm trying to come up with something that can work on a machine that doesn't have a human sitting at it. So this is why I didn't use Qt Creator to run my tests, for instance. Because if you have some kind of system automatically running tests all the time or nightly or whatever, it doesn't make sense to have that firing up Qt Creator to launch some test. So the same kind of thing applies. It sounds like your solution is useful to your developers, but as long as you're targeting kind of humans to run your tests and interpret the results, you're going to get some wrinkles.
So getting back to this input box example, I was wondering about the like generic UI functionality when a user enters something wrong and presses OK, and the general UI response would be to throw out a pop-up which would say something went wrong. So how the current test framework can handle this pop-up or any event thrown from the code?
Okay, so the specific thing that you mentioned that would cause a problem if my dialog were to pop up a dialog, because that would be modal, right? So control could not return to my test until after the dialog had been dismissed. So what I recommend in general is that you implement, well, in this example, I've implemented my own username and password dialog, right? So I have control over that. So that's not really an issue here. For the applications where it is an issue, it sounds like you're, again, interested mostly in system testing. So high-level testing, clicking on things, verifying the results. That's kind of out of the scope of, well, it's not really what QTested was built for. So there's no real nice way to address the problem.
Yeah, but potentially if we chop out the part of UI code from the already made application, the test will be possibly invalid at some point. So we can chop out enough UI and we'll end with the totally different application which works correctly, but the sum will not work. So. If we chop out enough UI parts, the actual tested application will be totally different from the intended application. So how possibly could this be addressed?
Okay, yep, I understand what you're saying, but I think that we've been a bit misled here by the fact that I'm testing something that itself simulates key clicks. I mean, in this example, let's say that the autotype functionality that I'm testing, it has a contract. It has a documentation that says when you ask to do an autotype, you get these key clicks followed by enter. And that's what I've tested here. And I'm testing that correctly. And I think that your question is a more general scope, not actually related to the example that I have. If you want to talk about that a bit more, then you can come see me afterwards.
So you've mentioned that the cleanup and setup code runs every time for each test case.
Yep.
In my experience, especially when you're testing against platforms, against some kind of a service, some kind of persistent, maybe storage, there are bugs that appear only once you've passed a couple of test cases. How can you cater for stacking fixtures between test cases?
Yep, so that's a good question. So we have some tests, we have had some tests in the past, for example, that do a series of SQL queries and verify the result after each one. And that test was still using init and cleanup, but since these are just C++ functions, we can also have a little a member variable that says whether or not the init or cleanup should actually be done. So we can set up our init and cleanup functions so we can kind of toggle between the two modes and get either stacking up results or clean every time. Any more questions? Yep, one over here.
What about testing multi-threaded applications?
Everything that I showed works fine for that. It's just that, as with everything, once you add multi-threading, then it becomes harder. But all the testing primitives that I showed, they work just fine. Do you have a more specific kind of difficulty? Or?
No, it's just detecting deadlocks and how to set up complicated tests, and these are very, very hard to track because they doesn't show up every time you do that.
Yeah, that's right. So actually, that is a good point, that when you are testing threaded stuff, it's very difficult to come up with stable tests. So you can very easily get into the situation where you have a test that seems to pass, but then once every 100th run or so, or even once every 1000th run, it fails. It's very difficult to figure out why. There's not really any tools provided by QTestLib to make testing threaded applications easier. There's just the stock standard thread APIs available in Qt. So there's no more tools than that to help you out, unfortunately. Okay, one more question.
Are these all the helper functions while we're on the topic of multiple threads, are they thread safe? So could I run verify and compare in multiple threads without messing up my data or the output data for the test results?
I have to say that I'm not really sure, and I wouldn't recommend writing a test that way. I think if you're writing tests with threads, usually the safest thing, actually this doesn't apply just to threads, it applies to a lot of kind of algorithms that you might want to test. It's good if you can do all the work and store the results, and then once control returns to your top level test function, that's where you do the verification. There's actually more problems with if you do a qverify within another thread, for instance, that has no way of exiting out of the test function that's in progress, which is what qverify normally does. So the problem that you mentioned is not the only problem you'll find if you write tests in that way.
Actually, I've seen tests for these thread things, and what you can do is like just execute the tested functions a couple of times, like 1,000 times, and really try to break this by interrupting it. If you have like multi-threading things, and send event while the other thread is working, and then you will see if you have problems there. So we have tests in Qt that do exactly things like that. Just 1,000 times, try something like with 1,000 threads, and then try to break it like this. You can't do this really with user testing.
Yeah, so that's another interesting point, actually. That approach that was just described, that's sort of the mentality of trying to catch as many bugs as you can. So some of the tests that you'll write, you'll just be trying to catch as many bugs as you can. Other tests that you'll write, you'll be trying to prove that your code works as documented. They're kind of two different testing approaches. So do we have another question?
I saw the test table in this example. Can we define and fill it at runtime?
Yes. So I did mention that. So the data function is just standard C++. You can put anything you want in there. So you can load it from you can load data from files from a database, whatever. But I also gave the warning that the more complex you make your test code, then the greater the chance that your test itself also has bugs. Okay, yep, still one more.
I only recently started with this testing stuff, and I was trying to unit test a new class. And I noticed that the test code was growing considerably faster than the actual class and was growing much bigger. I was wondering that there were a lot of trivial functions in there. Where do you stop? What is a reasonable size for your testing stuff?
Well, that is a very very open-ended question. So I would say it really depends on the target audience of your application. So if you're writing some kind of safety critical thing, for instance, it's not unusual to have a contract that specifies that you must have 100% test coverage. So when you run your tests, 100% of your code must be executed. If, on the other hand, you're just writing some kind of simple little game, maybe you can get away with just whatever tests that you feel comfortable with. Whatever is the right balance for you, really. Okay, I don't think there are any more questions, so thanks for coming along.